The video is about some basic concepts of electrochemistry. Electrochemistry, as its name indicates, it is composed of two words, electro, that is derived from electricity, chemistry, which means that there is some chemical change or chemical reaction. So we will study the electrical energy or electricity, and we will study a chemical change or a chemical reaction in the electrochemistry. So it is a study of electricity and how it relates to the chemical reaction, which means that we will provide the electrical current or electricity, and it will cause a chemical change in a system. Chemical reaction will occur, and that chemical reaction will be based on the redox reaction or oxidation reduction reaction. So it means that electrical energy here is converted into the chemical energy, or we can say that the electrical energy will cause a chemical change in a system. That chemical change will be the redox reaction. Another process which we study in the electrochemistry is the study of chemical processes that cause the electron to move. Here the electron, it means that there is an electricity, and the chemical process, it means that there will be some chemical change or chemical reaction that is known as redox reaction. Due to this redox reaction, electron will start the moving either towards the electrode or away from the electrode. So due to this redox reaction, that is a chemical process, it will produce electrons to move. So here the chemical energy or the chemical reaction or chemical process will produce an electrical energy. So the electrochemistry can be summarized as electrical energy, it will cause a chemical change in a system, that is a redox reaction, or a chemical reaction or a chemical process that is also a redox reaction. It will produce electrical energy or electrons. So electrical energy and chemical energy, these both will be studied in the electrochemistry. Electrochemical cell. What is electrochemical cell? It is a device that can generate electrical energy from chemical reaction. It means that there will be a chemical reaction that is normally redox reaction, and it will produce electrons, electrical energy or electrical current. Or we can supply electrical energy through battery, and it will facilitate some chemical reaction. So it means that these devices are able to converting chemical energy into electrical energy or electrical energy into chemical energy. Some common examples are 1.5 volt cell, which are used in many power electrical appliances such as TV remotes and clocks. Electrochemical cell is divided into two categories. One is known as galvanic cell or voltaic cell. In galvanic or voltaic cell, a chemical reaction will produce electrical current, or a chemical reaction that is a redox reaction, it will produce electrons. That means that the chemical energy will be converted into electrical energy. That is also a redox reaction. Redox reaction, which means that there is a loss or gain of electron. So here in galvanic cell, there will be some chemical reaction, there will be some chemical process. This chemical process will produce electrons. Another type of cell is electrolytic cell. In electrolytic cell, we will supply the electrical energy, and it will cause some chemical change. So here the electrical energy, it will create some chemical change or chemical process. That is also a redox reaction in which the gain or loss of electron will take place. So the electrical energy will be converted into chemical energy in electrolytic cell. In galvanic cell, the chemical energy or chemical process will produce electrical energy. Electrode is a point where current enters or leaves the electrolyte. Here the current means the flow of electron. The flow of electron will be either towards the electrode or away from the electrode, and it is the main component of electrochemical cell. It is divided into two categories, cathode and anode. In cathode, the electrons are consumed, while in anode, the electrons are liberated. Here the electrons are consumed and the consumption or the gain of electron is known as reduction. So the reduction reaction will occur at cathode. Here the electrons are liberated or electron are lost at the anode. So the loss of electron is known as oxidation. Electron will move towards the cathode and electron will move out from the anode. While writing an electrochemical cell, the cathode must be represented on the right hand side and the anode is represented on the left hand side. It is the specified position for the cathode and anode while we are writing or while we are drawing an electrochemical cell. Now this diagram will explain the complete functioning of anode and cathode. The two electrodes are taken. One is zinc electrode, another one is copper electrode, and these are dipped in the electrolytic solution. Here the loss of electron will take place from zinc electrode and the gain of electron will be at the copper electrode. The loss of electron is known as oxidation and the oxidation will take place at anode. So the zinc electrode will act as an anode. The gain of electron will take place at cathode. So the copper electrode will act as a cathode. Now the zinc electrode will lose the electron and it will produce zinc plus 2 ion that will move towards the electrolyte. The electron will move in the external circuit and it will move towards the copper electrode. Here the copper plus 2 ion from the electrolyte, it will gain the 2 electrons from the external circuit at the copper electrode surface and it will be deposited at copper electrode. Now here the loss of electron will take place and here the gain of electron will take place in the whole electrochemical cell, that is voltaic cell. Now we will write the cell notation for this cell. What is meant by the cell notation? It is a shorthand abbreviation of a chemical reaction in voltaic cell. We will write some symbols for this cell. Zinc electrode, that is in solid form, it is followed by the zinc nitrate or zinc sulfate salt, but here is an interface between zinc ion and zinc solid, and that interface is the surface of electrode. So this single line will show the interface. So zinc solid, it is separated by the zinc nitrate by this interface, and molarity is 0.1 molar. It is followed by the salt bridge. Here the double line will show the salt bridge. Salt bridge is dipped in a copper electrolyte that is taken as copper nitrate and it is followed by the copper electrode solid form, but here is also an interface present. So this single line will show the interface between the copper electrolyte and copper solid or copper electrode. If we simplify this formula, zinc electrode followed by the zinc ion followed by the salt bridge, then copper ion and copper solid. Now the anode will be always on the left side and the cathode will be always on the right side. Here in this cell setup, the outside components are the electrodes. This one is electrode and this one is electrode that are outside, and the inside or the inner components, that is copper nitrate and zinc nitrate, these are electrolyte or these are the salt solutions. Electrode potential, it is the tendency of an electrode to lose or gain electrons when it is in contact with solution of its own ions. If we take M positive as an electrolytic solution, an electrode M is dipped into it. So here the two phenomena will take place, loss or gain of electrons. If the M positive, it will collide with the surface of electrode and it will gain the electron at the surface of electrode and it will become M solid or M neutral form. So here the gain of electron will take place, which means that metal ion is reduced. It is represented as M positive and it will gain the electron, it will produce M solid. In another case, the M neutral metal that is present at the surface of electrode, it will lose the electron and it will produce M positive. So here the loss of electron will take place and the loss of electron is known as oxidation. So the metal that is in solid form that is present at the surface of electrode, it will oxidize and represented as M positive and electron will be lost. Electrode potential are divided into two categories. One is known as reduction potential, another one is known as oxidation potential. So if the electrode will act as a cathode, so it means that reduction will take place, so we will take reduction potential. If the electrode will act as an anode, so it means that there will be oxidation takes place, so we will take oxidation potential.